Good day, friends. We will be continuing again on chapter 1, and this will be our 5th video in this series. And I am going through each part very carefully so that you get a very good concept about the number. This number will be backbone for all mathematical operations you will be doing in future. This will be useful not only for class 9, but as you said that if you have good foundation, you would be able to build the similar thing in class 9, class 10, class 11 and class 12, and also in your future competitive exams. So there was one question which was missing in exercise number 1.3, and that we will be taking up now. So again, exercise 1.3, and this is question number question number 5 that we have not been taken up. I think I missed it. This is 1 upon 1 by 17. It's decimal expansion. DECI decimal expansion, right? So this is what we are going to do right now. So first of all, let us try with this one. This is long-handed method. So first it doesn't go, so put a point, so you get 10. It doesn't go, so you put a 0, so you get 100. Okay, so first one would be what? 5. That is 85. That gives you 15. And then again you have to put a 0 because you have this point here, and this would be 8. So if I use 8, 5 into 7 into 56 plus 5, that is 13. Okay, so that gives you 4 and 1 and 0. So again you have to do the same thing. 8, again 8, 136, then you have 40 here. 40 means 2 is 34, yes, 2 is 34, so you have here 6, and this is 6, so I will go up here so that we remain within our video view. So this should be 60. So 60 will be what? 3, 51. So it should be 351. So after 2, so this would be 51. So that gives you 90. 90 again, 85, it should be 5. Yes, 85, because we have used 5 before, so it will be 85. So then it becomes again your 50. Sorry, I should be writing it bigger. So this is becoming 50. Okay, after 50, so it will not, 3 will not go, it will be again another 2 will go. So that will be 2, I have used it before, so that is 34. So I will add up 34 here. So this is 6, and this comes here, so this is 414. This is again 60. So then in that case, I will again have a 7 here. Yes, I think I have not used 7 anywhere before. So this will be 7. What will be 7? 9 is 49. And 7 into 7, 49. No, it should be more than that. So 50, this is 16. So this should be more than 8. So this should be 9 here. So if I use 9, so 17 into 9, this is 63, and 6, so 153. So I think that should be a 9 here. 5 to 9, so 9 I will use 153, So 153, this is 7. So let me take it down again up here. So 70, 70, that will be 65, 65, 4 would be your 68. So this is 20. So 1, 17, 30, again 1, so that will be 17, and again 3, and here is 1. Okay, 3 and 1, so 130. So 130, which one will go? This is 136 is for the 5. So this must be again 4. So what is, no, it will not be 4, it is 136 is more. So double 8, so I think it should be another 7. So let us try a 7. 17 into 7. So this is 9. And this is 11. 119. So this is 119. So what does that give me? That gives me 1, and this is gives me 2. This is 1. 117. Then it will be 0, and then 117, and this will be 0. This is again coming. So have I used anything? Another one. This 0 will not be here. So let us add a 6. So if I multiply 17 into 6, we are doing 102. So this is 102. So I get a 8. So I will again, where do I transfer it? Where do I transfer it? This 8, I will remove this. Again, I have to do it, but it doesn't make any difference. So take this 8 here. So this is 80. So what will be, that was 85 for 5. So I think 4 was what? 4 was 68. I think again another 4 will go here. So this would be 68. 68. That will be 210. So multiply into 7. Have I ever have 119? So multiply it by 7. So these give me 119. So I get 1 back. Great. So this one is now being become repeated here. So this one is being repeated. So we end it here. So this is our decimal expansion, and we should have a bar here because it will be repeating here. So how many digits we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I come here on this side, 12, 13, 14, 15, and 16. So this 1 by 7 repeats after 16 digits. It repeats after 16 digits. So this is over. This is the one thing to learn from this exercise is that you have to have some amount of patience. You need to have some amount of patience to handle this kind of a what you called question, this kind of a question or examples to be done it. So now we will go to the next chapter. What is the next chapter on? Next chapter is a conceptual this thing. There is not much mathematics or this kind of a division. So what you have to learn about it is a concept of sometimes which may come on your mind and you may like to do it. So instead of getting confused about it, you should be able to handle it. And what is that called? I am following this thing. This is called 1.4 and this is representing real numbers. Real numbers on number line. So now this is important, real numbers. So that means we have to learn both about imaginary as well as irrational and rational numbers. Okay, now I am picking up the same example what is given in the book, and that is that suppose we want to locate 2.665 on number line. Now this section will be missed by many schools and many tutorial colleges. So as a result, I will like to emphasize it here a little bit. Now how it is done? It is known as a process called progressive. No, I would not call it progressive. It is successive. Successive magnification. What is the meaning of magnification? In case of magnification means you can use a bigger lens like this, the very big lens like this, which basically magnifies. So if I read it like this, it may not come in the this thing what you call in the video, but I can have a larger view. So this is only a getting a larger view of this thing. So this is called a magnifying glass. So what is it we will be using this? So for what is the first thing that I have to do? What is my first job? First job would be to draw a number line. So let me draw a number line. So this is a number line. Okay. So let us say our initial point is 0 here. So on this side it will be positive. So this is given as a positive. If there is no sign here, there is no sign here. So that means this is positive. Okay, this is my first thing. This is positive. So I'll be on this side of it. So 1, 2, let us say 3, let us say 4, let us say 5. This is 1, 2, 3, 4, 5. Equal divisions. These are all equal divisions, even though it may not look like it, but they are supposed they would be equal divisions. First of all, I see what 2.665 is 1. The 2.665 will be here, between 2 and 3. So I will take a magnified view of 2 and 3. Okay? Let us say this magnifies into 2 to 3 here. And I will divide into 10 equal parts. So this will be say 1, 2, 3, 4, 5, 6, 7, 8, 9. So that will be 10 equal parts because I don't have to go to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal parts. If I divide these 10 equal parts, the first one will be 2.1, right? So this will be 2.1, this will be 2.3, this will be 2.4, this one will be 2.5, this one will be 2.6, then this one will be 2.7, then this one will be 2.8, then this one will be okay, I think I have divided more, no 2.1, sorry, this is 2.2, that's what I am saying, how I moved one. Okay, so this one is 2.3, this one is 2.4, this one is 2.5, this one is, this one would be 2.5, this would be 2.7, this one would be 2.8, so this is 2.9. Okay, let's do it again. I think this is getting confused here. Okay, let's do it again. Nothing wrong. You sometimes get to do it 2 times. So let us say here, so this is 2, there is nothing wrong in it, this is 3, this one let me put it so that there is no problem, 2.1, so this is 2.2, next one is 2.3, next one here would be 2.4, next one here would be 2.5, this one would be 2.6, this one would be 2.7, this one would be 2.8, and this one is 2.9. Okay, so this is the division. All this is division. Now I have to go around and find out where again this one falls. Where this would be between 2.6 and 2.7. Where is 2.6? This one is 2.6, this one is 2.7. So here again I have further narrowed it down and I have got it here between, so this would be between 2.6 and 2.7. So you take 2.6 and 2.7 and you again magnify it. You magnify it what? How you magnify this? You magnify this one again the similar using a magnifying glass. I can't show you that magnifications because of my limitations, but you can conceive this that this is the way this is going to go. So I again draw this portion of the line, not the whole line. So I am going to draw this portion of the line, and I am going to take it from here 2.6 to, I will take it about 2.7. So, okay, 2.7. And again you further subdivide it into 10 equal parts. So let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, so what is this now becomes? This one becomes now 2.61. Okay. So I will skip this and I will go this one because here it will be, you can see how much confusion it is going to create, which made me go through a small correction. So I have to go through, I will do it this way, 6.1, next one will be 2.62, this one will be 2.63, and continue. So 6.3, this one 6.4, this one 2.65. Say, let us say next one, this one 2.67 because I have skipped this. This would be about 2.6869. So this is the way. I have divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one will be 10. So that should not be. So be careful. So this one will be 10. So I will move this one a little bit and I will do it like this. Okay, this was something extra that I have generated. So this is 6.9, 2.69. So basically, to make it in 10 divisions, you need 9 markings. Remember this, 9 markings. Okay, so you got 9 markings. So again 6.66, so that will be between 2.6, this is 2.6, so this is 2.6, and it should be between these two. So it should be between these two, right? It will be between these two. Again go through the same process of magnification, So let us do it. Again I will do it one time, and that will take care of a lot of problems, and that will be establish the concept. What is known as a successive magnification. You see, whatever was the point. So now what I am going to take up, I had between 2.66 and 2.67. So this division, I am going to magnify it. I am going to magnify that. So on this point, starting point, now it will be 2.66, and then this one will be 2.67. Again divided it into 10 equal parts. That means I need 9 divisions. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so then what is this one will be? This one will be, first one will be 2.661. Next one will be 2.662. Third one will be 2.663. I leave one here. So I will go to 2.664. I have left, so it should be 5. And then I will go to this, I will go to here, 2.666. This one will be, this is the fourth division, 2.661. And so I will concentrate on this. I am going up to 2.661. So if I divide it, 2.1, this is 2, this is 3, this is 5, this is 661. Okay, so this is the one I will have it then, 6.66. So this would be the point that I will have. So this is the point. So this is called as progressive, successive, successive magnification. Okay, so this is, you get it, magnified it by so many markings. So okay, so this would be 2.6, this would be 5, 6, this would be 7, this would be 8, this would be 9, and this would be 2.6 and 7. This would be 2. The next one to that, 2.77. Okay, we will do it this way. Okay, so this is progressive, this one. Okay, there is another, I will not repeat the another one which is given in this thing, which has got not much of importance. This is the way. I hope you have understood the concept of this representative on the number line. Okay, now we will go around and bypass one exercise 1.4 because this is basically on the same one. Only thing I will pick up one particular point in order to introduce to you a concept, and that concept is very this thing that you must know or you should look for it. Yes, it says visualize. This is again example 11, and this says visualize representation. Visualize the representation of 5.37 on a bar here, on number line. Acha, now as soon as you see this, that means it keeps on repeating. So you need how many places you have to go after the decimal point. So he says up to 5 decimal points. This is important. Okay, I don't want to go to this thing because this will be the repetition of the previous one. So anyway, we can go through it again. I will go through it. So 5 decimal points means 5.3. This is already 2 decimal points. So 777. So this is what he is going to try. And this goes on, but we don't have to go. He says do it only up to this. So what do we have to do? Again, let us get this example. Then you will be also able to do a whatever this thing with repetitions. That means that is also a rational number. So let us see how it is done, and this should be done very, very easily. Again it says, on the top we write 5.3 so that we don't get confused. 7, 7, 7, 7. So this is between 5 and 6. So 5 and 6, there is nothing to worry about. So this is 0. So this is 1, 2, 3, 4, 5, 6. So I will pick up only this thing between 5 and 6. This one I will pick up, I will magnify this. Okay, and leading to 5 divisions, 10 divisions. Okay, so let us say here is 5 and let us say here it is 6. Okay, let us first do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then another, this one will be the division 6. So pick up what is it between 3.3. This would be, I will do it little bit differently, 5.1, 5.2, 5.3, 5.4. Okay, do I have to go further than that? No, I will pick up. Okay, but let us see my divisions are correct or not. So this is 5.5, this is 5.7, this is 5.9. Okay, so my divisions are okay as I have told you before. So then I will pick up, what do I pick up here? I pick up between 3 and 4. So I pick up this portion between 3 and 4. Okay, I pick up between 3 and 4. So I will again divide the portion between 5 and 4. In order to get this one. Okay, let us do that again. So I have this portion. So this is being magnified, not the whole number line. Remember that. So let us start here. The first one will be 5.3. Right? Dividing into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one will be 10. Okay, so this is what would be this? This would be 5.4. So how do I start? I will start it 5.31. Okay, next one I will leave, next one will be 5.2. This one I will mark 5.3. I will leave this, I will mark this one 5.5. This one I will mark as 5.7. And this one 5.9. And of course this is this was 5 point, no, this was 5, sorry, this is 5.3, 5.32, this is 5.33, this is 5.3 to right guy, 5.35, this is 5.37, this is 5.39, and this would be 5.4. Okay, so remember like this 3 should, this is you are dividing between this. So if you have divided between this, now this is, I have to pick up between 5.37, this point, and 5.38. Okay, this one I will pick up. And I will pick up and then again subdivide this. So see this concept. So you are again subdivide it, and to subdivide it I have to magnify. So this is becoming successive magnification. 1, this was the second, this is third magnification. Third magnification. So here what I will start with, the first one here would be 5.37. Okay, so let us start again 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this will be 10. Okay, and what will be that 10? That this would be 5.38. Right? So this point will be, now I have got a little bit space here. So this should be 5.371. This you remember. Okay? And this one would be 5.373. And this one would be 5.375. This one would be 5.377. This one would be 5.379. Again look at it. 5.377. 5.377. So this is this one. So that means this one is 5.378. So I have to again pick up this one and go through again another subset divisions. Okay? So this you keep on doing it and being careful that what is your starting point and what is your end point. Okay? So you take this one, again you take this thing. So I will go through another process. So this is third magnification. What do I do in the fourth magnification? Again I will take this line. So this is my 5.377, right? So divide it again. This interval you divide. So that is what is your interval. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the 10. So what is that? 5.378. Okay, what it would be? This one would be what? 5.3771. Okay, so you remember this. This would be, I will skip one because there is less point to write, and this is becoming bigger. So I can remove the 5 and I can write, and I hope all of you will understand. I will write 337, this is 2, and this would be 2. Okay, I have started with 5, 1, 2, 3, and this is the 4th point it is coming. 1, 2, 3, 4. Okay, and I have to go up to 7. This is a long way to go. So 3, this is 4. So this is 1, this is 2, this is 3. So this is not 2, this is 3, because I have skipped 1. I will again get into problem. So this is 0.37755, because 4 I have skipped. So 5, so I will skip 6 and I will come to 7. So 0.3777, right? So this one will be again 0.377 8. So 8, 1, 2, 3, 4, 1, 2, 3, 4, 7, 8. So are you getting the concept? So this one would be, okay, so 7, and this would be within that area. So this is 771. This is 3.772. This is 779. So this is 3.5779. So this is 4 places of decimal. Okay, what do I have to choose? I have to again choose this one and keep on magnifying. So I think you will be able to do it later on in your this thing. So you again magnify this, and then you will be able to reach these particular points. So you have to keep on successive magnifications. You have to keep on successive magnification. So we can say that every real number is by a specific point on the number line. So this is what is it? This is, if I write P and Q all the time. P and Q is the number line. Okay, I have not gone through the completion because that is a repetition of the same thing. And then you would be able to, I hope you have got that concept here. Okay, so I'll skip this and then I will go. So exercise 1.4, this is the same thing, 3.675 on the using successive magnification. And so exercise 1.4, exercise 1.4 is on successive magnification. And I hope you got the concept. The whole concept of magnifying and doing it. And you have to do it little bit carefully so that you know what exactly you are doing it. All you have to do it, again take it up and go up to 3 places of decimal. Here I have gone up to 4 places of decimal. I have gone up to 1, 2, 3, 4. So you have to go for another decimal place, and that you can do it here. I will leave it to you, your ability to it. If you don't have, if you have a problem, please call me 940-751-8512 if you feel any problem. Again, I will take this point to request you to like my channel and to like this video and to subscribe to my channel, because I need those subscriptions so that all subsequent videos will come to you automatically. You don't have to search for it. And then you can go through it and see what is happening, what new videos have been done. I have told you this channel is first dedicated to class 9 and to mathematics. We will pick up other channels subsequently. Okay, now This is operation on real number. Here I will go through a little bit slowly. So operation on real numbers. You know how we are going to do this operation? What is first mathematical operations? What is this mathematical operations? You know the mathematical there are four. One is addition, the other one is subtraction, third one is multiplication, another one is division. Okay, there are minor other one that is called brackets. There is another one is called brackets, and this is this will be the first bracket. This is the second bracket, and this is the third bracket. Okay, these are also mathematical operations, but their major mathematical operations are these three. Okay, now you can see that addition and subtraction, the addition and multiplication, they are practically similar, these two. Unfortunately, in our school, instead of teaching addition and then multiplication, we go first for subtraction. And subtraction and division, they are similar. Because in case of addition, A, so it should be 4A. Or I can multiply 4 into A, that is equal to 4A. So I can say multiplication is a much faster addition. So if you have similar things, you can easily add by multiplying. So the A should be similar. Otherwise you have to separate them A, B, etc. So this will be easy. Okay, so these are the operations. Now what I am going to do is there are some laws which is applicable. So they are called commutative. Commutative. Then there is also associative. And diversitative. So what is this diversitative laws are these things, and they are instead of diversitative, I am sorry, I'll change it to as followed in the book, because I think others will be able to do this thing. This is known distributive, and that is more appropriate. Distributive. So there is 1, 2, and 3. These are the laws. And they are applicable. What they are applicable? Applicable in addition and multiplication. But not for subtraction and division. And this should be a revision for you, because this you must have done it in your earlier class of 5 and 6. You must have done it. So this is it will be very easy. Why I'm saying doing it? Because it's in order to refresh your memories. Because you may not have given the importance to this chapter, what is required actually in order for you to understand lot of things in future as well as in this class. Okay, as well as in your competitive exam, you need to understand these things. Okay, what are these laws? These are simple things which you are doing it without knowing it. What is this? A plus B, this is the first is commutative law. A plus B is same as B plus A. We have been doing it. But look at this. Let us see. 2 plus 5 is equal to the same as 5 plus 2, that is equal to 7. We have been doing it. But can I do it if there is this thing? Say, let us say here, 2 minus 5 is what? Minus 3. But if I flip, 5 minus 2 is equal to plus 3. So see the changes? The change is happening. But here there is no change. So this commutative law, this is the law, it doesn't work for multiplication, for subtraction. So be careful about it. Array, I have learned it in case of this law, so why don't I apply it here? Okay, so this is number 1. Okay, second one I said associative, right? That was, this is, this is also the same language, associative. What does it mean, associative? Associative, there is no example, but anyway, if you take an associative law, again this one, what it says, A plus, let us say B plus C. That is same as I can say B plus A plus C. Or that is also equal to, I can say C plus B plus A. So changing it, changing this association from here to here, it doesn't make any difference. Okay, so I'll do it. This is for addition. Okay, now let us see the other one. Other one is distributive. Distributive. And we have been doing it all along. Distributing, same, you distribute the way you want it. So it can be distributed, C, as I said, C plus A plus B, that you keep on distributing. This becomes more important in case of multiplication, which we'll pick up now. So this is distributive law. So there are 3 laws. This is number 3. Now this is number 2. 1 commutative law, we have discussed 1. And we have discussed in terms of the addition. Subtraction, we have shown that this doesn't work because the change in position changes the value of the line in it. Okay, now let us see in multiplication. What happens in case of multiplication? Let us say first one was, what was first? Commutative. What was first? A into B is same as B into A. Okay, doesn't matter changing. Say let us say 2 into 3, that is equal to 6. Then this is 3 into 2, that is also 6. So having different positions doesn't this thing. But this does not apply in case of division because A by B, okay, let us take the same example. A by B, let us say 2 by 3, okay, this is its one value. If I flip it over, that means if I do B by A, that means this becomes 3 by 2. The value is different. This is 1.5 and this should be about 0.66 something. Right? So this does not happen in case of division. So for division, this law does not work. Okay? So this is cumulative. What is then again comes associative. Associative multiplications, what will be there? Associative. Again the similar way. Let us say A into B into C. Okay. So you can also write, multiply that AC into, you can also write B, or you can write B into A into C. So this you can keep on doing it. So this, the maximum advantage that will be give you is distributive law. What is that law says? The law says, suppose you want to multiply 105 into, let us say 25. What you can do? So this is multiplication. So what you can do? You can distribute this 100 plus 5 into 25 and add them. Okay? Multiply this with this and multiply this with this. So bigger numbers. So this is again, let us say you want to multiply something like 999 with, let us say 23. So what you can do here? You can distribute this into 1000 minus 1. You can do it and then multiply with 23. And this is much easier. You will end up doing it in a much simpler way, this kind of multiplication. So this comes due to distributive law. I think we can stop it here. And then I will again request you to like my this video and or comment on this video. If you have anything to comment that this could have been done this way, I will appreciate your comments. At the same time, you can subscribe to my channel. These subscriptions are totally free, so then you can subscribe to it. Thank you.